In this demonstration, I'll show you multiple examples on how to use the quotient rule to find the derivative of a function. Now in calculus, the quotient rule is used whenever you have two functions divided. Here's the general use pattern of the quotient rule. Notice that you square the denominator and then you take the denominator as a function and multiply it to the derivative of the numerator. And then you subtract the numerator function by the derivative of the denominator. Let's get started with question number 1. We'll start off by squaring the denominator. 2 minus z to the power of 2 all over gx 2 minus z and f of x. The derivative of this will be 3. And then we subtract the function above, which is 3x plus 9, multiplied by the derivative of the bottom, which will equal to negative 1. 2 goes to 0, that goes to negative 1. You can simplify the top. 6 minus 3z, and then minus negative 1 times 3 is negative 3x. Negative 1 times 9 is equal to negative 9. I'm just going to continue to simplify this. 6 minus 3z plus 3x plus 9. That cancels out, and you end up with 15 over 2 minus z to the power of 2, which is the derivative, first derivative. Let's proceed on to the next question. This one's slightly more complicated because we are introducing a radical, but the same concept applies. We're going to start off by squaring that, and then we're going to take this, put it up here, and find the derivative of the top. The derivative of the top is equal to, now remember, 4 the square root of x is the same thing as saying 4 times x to the power of 1 over 2. And we're going to use the power rule here. We're going to bring this down. 4 times half x to the power of 1 over 2 minus 1. 4 times half is 2. This subtracted is equal to negative 1 over 2. And that is equal to 2 over x to the power of 1 over 2, or the square root of x. We're going to place that right here. And we will now leave this the way it is. 4 square root of x multiplied by that, 2x minus 0. So this right here is the derivative of g of x. And now what you would do is simplify this. This is going to be a little bit hard to simplify because of this square root situated in the denominator position, but it's still possible. This multiplied to that is equal to 2 times x squared over the square root of x. This multiplied to that is equal to negative 4 square root of x minus 8 square root of x times x. Now, of course, you could simplify this even further, but then we would be spending a whole lot of time doing simplification. So this will do for now. Let's move on to question C. Once again, we'll start off by squaring the bottom. And this can be simplified. Keep that in mind. G of x is going to be placed right here. Then we find the derivative of 4, which is 0. Minus, we're going to leave 4 the way it is and find the derivative of the bottom. The derivative of the bottom will be 6x to the power of 5. We're going to simplify this. And we end up with this going to 0 minus 24x to the power of 5 over x to the power of 12. This simplified becomes negative 24 x to the power of 5 over x to the power of 12. This goes to 0, and this goes to 7. So we're left with negative 24 over x to the power of 7. Let's move on to question D. Now at first glance this looks like a candidate for the quotient rule, but do not be fooled. This is the same thing as 1 over 5 x to the power of 6. And with that said, we can easily use the power rule here. Bring this down. 1 over 5 times 6 x to the power of 6 minus 1, which is 5. So we end up with 6 x to the power of 5 over 5. And finally, in our last question, we have this function divided by that function. So we'll start off by squaring the bottom. And then bringing this up here. Finding the derivative of the top, which is going to be 0, minus the derivative of 4 times e to the power of x is 4 e to the power of x. And the derivative of 3x is 3. We're going to leave 5 the way it is. We're going to simplify the top. This goes to 0. That goes to negative 20 e to the power of x minus 15. Because 5 times 3 is 15, and this negative. And at the bottom we have 4ex plus 3x squared. So there you have it. Those are 5 solid examples on how to use the quotient rule in calculus.
If you found this tutorial helpful, please support our channel by subscribing or by liking this video. If you have any further questions, you may visit our website at biology-forums.com. We are an online service for students seeking free homework help. See you soon.